Okay, 7th grade, this is the Chapter 3 Study Guide number 1 video. As we come to each problem, I want you to pause the video and try the problem on your own first. And after you try the problem on your own first, then play the video, and as you watch me do it, you can check your answer. Okay, so you try it first, and then check your answer by watching the video. In number 1, it says, what is the product of negative 1.82 and 4.15? Okay, so first off, you see the word product. What is the product? Well, we know that the product is the answer to a multiplication problem. And so if you want the product of some numbers, you're going to be multiplying some numbers together. In this case, we're multiplying numbers with different signs, right? We're multiplying negative 1.82 and positive 4.15. And if we have different signs, we're not going to say subtract, right? Because we're not subtracting here, we are multiplying. So I would say same signs positive and different signs negative. And so I know that my product is going to have a negative sign, right? My answer is going to be negative something. And so since I have established what my answer will be, what kind of sign my answer will have, I can ignore the signs and multiply these numbers. Now remember, when you multiply decimals, you do not have to line the decimals up, okay? You just ignore the decimals and multiply as normal. Now, because these numbers both have 2 digits after the decimal, they're going to be lined up, okay? But they don't have to be when you multiply decimals. Just keep that in mind. So let's ignore the decimals and multiply as normal. 5 times 2 is 10. 5 times 8 is 40, plus 1 is 41. 5 times 1 is 5, plus 4 is 9. Okay, so I've used that, I've used that, I've used that. Add placeholder 0. Continue multiplying. 1 times 2 is 2, 1 times 8 is 8, 1 times 1 is 1. Okay, so I've used that 1. Add 2 placeholder zeros. 4 times 2 is 8, 4 times 8 is 32, 4 times 1 is 4, plus 3 is 7. Okay, it's very important to line all of your numbers up. Do you see here how I have sort of invisible columns? Right, there is a column right here, and here, and here, and here. All of my numbers are stacked on top of one another. This is very, very important so that I don't make any mistakes when I go to add. Okay, so now let's add here. These are all 0. 1 plus 2 is 3. 9, 8, and 8. Well, 9 and 8 is 17. 17 and 8 is 25. 2, 1, and 2, that's 5, and here I just have a 7. So those are my digits, 7, 5, 5, 3, 0. But remember, when you multiply decimals, you have to place your decimal at the very end. And you place your decimal according to how many digits are after the decimal point in both of the numbers that you multiplied. So look at my original numbers that I multiplied. 1.82, this has 2 digits after the decimal. And this number, 4.15, I have 2 digits after the decimal. And so in total, I have how many digits after decimal points? I have 1, 2, 3, 4. 4 digits are after the decimal point. And so in my answer, I should have 4 digits after the decimal point. And so in order to have 4 digits after the decimal, that would need to go right here, right between the 7 and the 5. That way there would be 1, 2, 3, 4 digits after the decimal. Okay, now remember, we said our answer would have what kind of sign? Our answer, because they have different signs, our answer would be negative. And so our answer is going to be negative 7.553 or 7.5530. Okay, that's number 1. Let's move on to number 2. Again, you try number 2 on your own and then come back to the video and check your answer. Number 2 says Zoe walked 2/6 mile. Angelina walked 1/3 mile. What fraction of a mile did they walk in total? Okay, so we want to know how much they walked in total. We need to add up their distances, right? Zoe walked 2/6 of a mile, and Angelina walked 1/3. And so if I want to know how far is this in total, I add them up. Because I'm adding fractions, I have to have a common denominator, okay? And so I like to write the problem vertically, up and down. 2/6 plus 1/3, right? That would be vertically, up and down. Now let's get a common denominator between 3 and 6. Well, I can get 3 to be 6, right? I can do that by multiplying by 2 over 2, right? Remember, when I create what is called an equivalent fraction, I must multiply the top and the bottom of the fraction by the same number. And so this 2/6 is going to stay the same. I'm just going to simply slide it over. It's going to remain 2/6. Now here, when I multiply 1 times 2, I get 2. And when I multiply 3 times 2, I get 6. Okay? So what we're saying is that 1/3, the fraction 1/3, is equivalent to 2/6. Now because I have a common denominator, right, in both of these fractions, my denominator is 6. Because my denominators are common, now I can add them, right? I am adding. So I have 2/6 plus 2/6. Well, when I add fractions with a common denominator, the denominator stays the same. So my bottom number is 6. And all I do is add their numerators. So I add their top numbers. 2 plus 2, well, that is 4, right? So my answer is 4/6. But is this simplest form? Well, I know 4 and 6 are both even numbers, right? And I know all even numbers are divisible by 2. And so to get this in simplest form, I could divide the top and the bottom by 2 over 2. And I would get 4 divided by 2 is 2, and 6 divided by 2 is 3. So the fraction 4/6 in simplest form is 2/3. And that should be your answer for number 2. They walk 2/3 mile. Right? 2/3 mile should be my label. Okay, you pause the video and try number 3. Number 3 says, what is 5 3/8 written as a decimal? 5 3/8 written as a decimal. So we're taking a number from a fraction to a decimal. Okay, so we have, this is number 3, the number 5 3/8, which of course you can see is a mixed number because we have an integer and a fraction together, okay? Now 5 3/8, this is simply the same thing as 5 plus 3/8, right? If I take 5 and add 3/8, well, that's the number 5 3/8. And so to make this a decimal, if I can figure out what 3/8 is as a decimal, then I could add 5 plus 3/8 as a decimal to get the number in decimal form. So let's take 3/8 and write it as a decimal. Again, this fraction bar right here means divided by. And so I have 3 divided by 8. And so we've talked about in class how the fraction falls over on its side, right? This fraction falls over. And so the top number, 3, goes inside the division bracket, and the bottom number, 8, goes outside. This is 3 divided by 8. Now, 8 can't go into 3, right, because it is too big. And so what I need to do is add placeholder zeros after the decimal. Okay? Now, my decimal, when dividing, goes straight up into the quotient. So the decimal is right there. We already said that 8 cannot go into 3, right? It goes in 0 times. Can 8 go into 30? Well, 8 goes into 30 3 times, right? Because 3 times 8 is 24. I would subtract and get 6. Bring down that next digit. 8 goes into 60 7 times, right? Because 7 times 8 is 56. I would subtract and get 4. Now I have to add a placeholder 0 so that I can bring it down and continue dividing. And 8 goes into 40 exactly 5 times. Okay, and as you can see, I get remainder 0, which tells me this is a terminating decimal. So 3/8 in decimal form is 0.375, right? But we're not asked what 3/8 is as a decimal. We're asked what is 5 3/8 as a decimal. And so I have 5, this is equal to 5 plus, what's 3/8 as a decimal? This is 3/8 as a decimal, right? 0.375. Okay, and so what is 5 plus 0.375? Well, that is simply 5.375. Okay, so 5 3/8 as a decimal is 5.375. Okay, go on to number 4. Try number 4 on your own, and then come back to the video after you've tried it on your own. Okay, so for number 4, you read the problem. It said, Alyssa cleaned 1/4 of her room on Thursday and 3/5 of her room on Friday. Alyssa finished cleaning her room on Saturday. What fraction of her room did she clean on Saturday? So Alyssa on Thursday, I'll put TH. On Thursday, she cleaned 1/4. 1/4 of her room. Okay, on Friday, I'll use F for Friday. On Friday, we are told that she cleaned 3/5. So she cleaned 1/4 on Thursday plus 3/5 on Friday. And she also cleaned, I'll use SAT, on Saturday, she cleaned some amount, which we don't know, right? And in total, she cleaned one whole room, right? One whole room. She cleaned her whole room after Saturday. Okay, so because we're adding fractions here, 1/4 plus 3/5, because we're adding fractions, we need a common denominator. And so what would a common denominator be between 4 and 5? What would the least common denominator be between 4 and 5? Well, you should say 20, right? And so what we need to do is get these fractions to have a bottom number of 20. Okay, this should be 20. How did we get from 4 to 5? What did we multiply by? Well, we multiplied by 5, right? Because 4 times 5 is 20. And so if we multiply by 5 on the bottom, or in the denominator, we must multiply by 5 in the numerator. Well, 1 times 5 is 5. So 1/4 is the same thing as 5/20. Okay? Well, let's do the same thing for the fraction 3/5. Okay, we want the bottom number to be 20. How did we get from 5 to 20? Well, we multiplied by 4, right? Because 5 times 4 is 20. And so if we multiply by 4 in the bottom, we do the same thing in the top. 3 times 4 is 12. Okay? So on Thursday, she cleaned 5/20 of her room, and on Friday she cleaned 12/20 of her room. So on Saturday, how many 20ths did she clean so that she cleaned one whole room, or 20 over 20, right? Because all of our bottom numbers are 20, and would you agree that 20 over 20 is just an equivalent fraction for 1, right? We could say 20 divided by 20 is 1, right? 1 whole. In this case, the whole is the room. And so because we're adding fractions, we keep the bottom number the same, right? Bottom number stays 20. And all we're doing is adding the top numbers, right? We're adding 5 plus 12 plus something should equal 20. Well, 5 plus 12, what is this? 5 plus 12, that's 17. 17 plus something equals 20. 17 plus what equals 20? Well, this something would be 3. Right? And so on Saturday she cleaned 3/20. 3/20 of her room. And so now if you take what she cleaned on Thursday, she cleaned 5/20 on Thursday, 12/20 on Friday, and 3/20 on Saturday. If you add 5/20 plus 12/20 plus 13/20, you would get 20/20, which is just 1, right? 1 whole room. So your answer is 3/20 for number 4. Okay, go on to number 5. Try number 5 on your own. And then come back to the video. Okay, so in number 5 it says a box of granola contains 16.8 ounces. It costs $5.19. What is the cost to the nearest cent of the granola per ounce? So we want the cost per ounce. Cost per ounce. Okay, we paid $5.19, so $5.19 per. That is another way to read this fraction bar. I could say $5.19 per how many ounces? 16.8. Okay, and so that is my rate right there, right? That's how much I'm paying for those 16.8 ounces. And we could also read the fraction bar as division, right? $5.19 divided by 16.8 ounces would give us the cost per ounce. Which is what we are looking for. Okay, so let's set this up. Because we can read this as a fraction, we know the fraction falls over on its side. We would have $5.19 divided by 16.8, right? Top number inside the division bracket, bottom number outside the division bracket. Now, because I am dividing decimals, I know that I cannot have a decimal outside the division bracket. And so I need to move it so that it's no longer a decimal outside the division bracket. Now, if I move this decimal one place to the right, it would no longer be the number 16.8, it would be 168. And if I move the decimal one place to the right on this number, I must also do the same thing to this number. I move this decimal one place to the right. And remember, moving the decimal one place to the right is the same thing as multiplying the number by 10. Okay, so basically, I multiplied both numbers by 10. So now, after you've moved the decimal, you need to rewrite your problem so that you can see what you have. Inside, this is no longer 5.19, this is 51.9. Outside the division bracket, the number is no longer 16.8, it is the number 168. Okay? Now I can divide as normal. Of course, when I'm dividing, the decimal goes straight up into my answer, so the decimal is right there. Now, can the number 168 go into 51? No, right? It's too big. It goes in 0 times. And so right away, we know that this number is less than 1. Now, can 168 go into 519? Yes, it can. And so you need to figure out how many times can it go in there. Well, more than once, right? What about twice? What's 168 times 2? See if that number is bigger than 519. If it's not, can you get any closer? Try 168 times 3. What is 168 times 3? If you do that, you should get 168 times 3 is 504, right? And that's pretty close to 519. If I were to try 168 times 4, I would be over 519. And so 168 goes into 519 3 times. 3 times 168 is 504. I subtract and I get 15. I got to add a placeholder 0 so that I can bring it down. So now I'm asking myself, how many times can 168 go into 150? Well, it can't go in there, right? It's too big. And so 168 goes into 150 0 times. 0 times 168 is 0, and so I would subtract and still get 150. Of course, I need to add a placeholder 0 so that I can bring it down. Now the question is, how many times can 168 go into 1500? Again, you need to pick an integer and just try it. Well, we know it's going to be more than 3 times, right? Because 3 times 168 is 504, and we're looking for how many times can 168 go into 1500. And so let's try 6, let's try 7, let's try 8. And if you try 8, 8 is actually correct because 8 times 168 is 1344, which is as close as you can get to 1500 without going over it. Okay? 1500 minus 1344, you should get 156. Bring down the next digit. Now, because we are dealing with money, we don't have to have an exact answer here. We don't need to keep adding digits here because when dealing with money, money only has 2 digits after the decimal point. And so, right now, here's my decimal point. I have 1 digit, 3, second digit is 0. And so basically, I don't need any of the rest of these digits. But what I do need to do is look at the third digit after the decimal. 1, 2, 3. I have to look at that digit right there. This is very, very important. I look at the third digit after the decimal. And because the problem asked me to round to the nearest cent, what is the cost to the nearest cent of the granola? I need to round. Is this number closer to 30 cents or is it closer to 31 cents? And because this digit, the third digit after the decimal, is bigger than 5, right? 8's bigger than 5. This would tell me to round this number not to 30 but to 31 cents, right? It would tell me to round this digit 0 up to the next digit 1. And so my answer is going to be it's 31 cents. It's 31 cents per ounce, right? It costs 31 cents every ounce. That's number 5. Okay, you try number 6 on your own. Try number 6 and come back to the video after you try it. Okay, number 6, it says no one had $60.25. So he had $60.25 in his bank account on Monday. He deposited $18.25, and if you deposit money, money is going in, so he put $18.25 in, right? So if I add these together, now he has $78.50, right, in his bank account. He withdrew $26.50. If you deposit, money goes in. If you withdraw money, money comes out. And so out of this money, he is taking out or withdrawing $26.50. Because I am adding and subtracting decimals, do you see how my decimals are lined up? I bring the decimal straight down into my answer. $78.50 minus $26.50, I'm going to be left with $52, right? He is left with $52 in his bank account on Thursday. Okay, you try number 7. Come back after you try it on your own. Number 7, a recently chopped down tree is 11 1/4 feet long. Into how many 1 1/8 foot logs can it be cut? Okay, so we've chopped down this tree and we have 11 1/4 feet of tree. And we want to see how many 1 1/8 sections can we cut this into. And so basically we're taking our total tree, our total stuff, 11 1/4, and we're dividing it into 1 1/8 sections, or in this case, logs. So we're dividing mixed numbers. When dividing mixed numbers, I would make them improper and then operate. So let's use the C method to make it improper. 4 times 11 is 44, plus 1 is 45 over 4, right? So 11 1/4 is the same thing as 45 over 4. I'm dividing. Now let's make this one improper by the C method. 8 times 1 is 8, plus 1 is 9 over the original denominator 8. So 11 1/4 is the same thing as 45 fourths, and 1 1/8 is the same thing as 9/8. Now because I'm dividing fractions, I know that dividing by a fraction is the same thing as multiplying by the reciprocal. And we can remember this by using KFC, right? Keep, flip, change. K is for keep. Keep the first fraction as is. So 45 over 4. I keep it as is. F is for flip. And when I flip a fraction, that means I'm taking its reciprocal. And so here I'm going to flip this second fraction. Instead of 9 over 8, it's going to be 8 over 9. So I keep, I flip, and then I see I change. I change from division to multiplication, which I'm going to use as a dot. Okay, now, because I'm multiplying, let's see, can I cross simplify? Well, here I have 45 over 9, and I know that 45 over 9 is the same thing as 5 over 1, right? Because 45 divided by 9 is simply 5. I know that because of my fact fluency. I also know that 8 over 4 is the same thing as 2 over 1, right? Because 8 divided by 4 is 2. So now that I've cross simplified, I need to multiply the top numbers. 5 times 2 is 10, and on the bottom I have 1 times 1, and if the denominator is 1, then it's not needed. So I have 10 what? What did the question ask me? It said into how many 1 1/8 foot logs can it be cut? So it can be cut into 10 logs for number 7. Okay, you try number 8 on your own. Come back to the video once you've tried it. Number 8 says Samara purchased a computer on sale. The original price was $900. The sale price was 2/3 of the original price. How much did Samara pay for the computer? Okay, so she bought this for 2/3 of the original price. 2/3 of the original price. Anytime you see the word of in math, that is a key word that signals multiplication. And so for number 8 here, she's paying 2/3 of, or 2/3 times the original price. 2/3 times 900. That's how much she paid for this computer. And so let's write both numbers as a fraction. So I have 2/3 times 900 over 1, right? That would be 900 as a fraction. Now, can I cross simplify it all? Well, yeah, I can, right? 2 over 1 is already simplified, but what about 900 over 3? Well, 900 over 3 is simply 300 over 1, right? Because 900 divided by 3 is 300. So I have 2 times 300, and 2 times 300 is 600, and this is dollars, right? That's how much she paid for the original, or for the computer, right? It was 900, she paid 2/3 of that, and 2/3 of 900 is 600. In this case, $600. Okay, you go on to number 9. Try number 9 on your own and come back once you've tried it. Okay, number 9, profits at Naya's craft shop decreased $1,015 in 5 days. So $1,015 in 5 days. What was the average decrease in profits per day? So we're going to take our total decrease. It decreased in total this much over 5 days. Our total decrease over the number of days. And so if I view this horizontal fraction bar as divided by, I would divide the top by the bottom, and that would give me the average decrease per day, which is what I'm looking for. So top number inside 1,015 and bottom number outside, right? 5 goes into 10 twice because 2 times 5 is 10. I subtract, bring down the next digit. Now, can 5 go into 1? Nope, goes in 0 times. 0 times 5 is 0. I subtract 1 minus 0 to get 1. Bring down the next digit, and I know 5 goes into 15 3 times exactly. So our remainder is 0. We know that is it, right? It is terminating. And so what is the average decrease per day? Well, it's $203 average decrease per day. That answers our question. It went down $203 for 5 days, which tells us in total went down that much. Okay, you go on. That was number 9. Number 9, $203 average decrease per day. Go on to number 10. Last one, number 10, you try it on your own. Come back to the video once you've tried it. Okay, it says Caden drove 45 miles in 0.75 hours. What was the average rate that he drove in miles per hour? Okay, so we want miles per hour. Miles per hour. So I'm going to put miles on top and hours on bottom. Well, the problem tells me that he drove 45 miles in 0.75 hours, right? And so because this is a fraction now, I wrote it as a fraction, I can take the top and divide it by the bottom, and that would give me the average rate, or the miles per 1 hour. So 45, top number inside, bottom number outside, right? Top number inside, bottom number outside. Because I have a decimal outside the division bracket, I must move it. In this case, 2 places to the right, which is the same thing as multiplying by 100. Now, if I move this number, this decimal 2 places to the right, I must do the same thing to this number. I don't see the decimal. Where is that at? After the last digit that I do see. I can add placeholder zeros. I move the decimal 1, 2 places to the right. So as you can see, I did the same thing to both numbers. I did the same thing to this number and this number. So now, after you have moved the decimal, let's rewrite the decimals, or rewrite the problem so that you can see what you have in the problem. The number inside is no longer 45, it is 4,500, 4500. The number outside the division bracket is no longer 0.75, it is the number 75. Okay, now 75 can't go into 45, but can it go into 450? Okay, yes it can, right? 6 times, because 6 times 75 is 450. I subtract and get 0, bring down the next digit. Now, can 75 go into 0? No, it can't, right? It goes in 0 times. 0 times 75 is 0, so you get 0 as your remainder. So, how many miles is Caden traveling per hour? Caden is traveling this many miles per 1 hour, right? 60 miles per hour, or I could write 60 mph, miles per hour. That is number 10. Okay, so now you have all your study guide completed. Again, make sure you've shown all your work. Circle final answer. Then go on to work on Chapter 3, Study Guide number 2 worksheets, pages 3 and 4 in your binder.